Stars are always there. 1,000 years, 10,000 years, 10 million years, they're the same. But one night you take out a sharp digital image taken last night expecting to see the same twinkling stars. But one's missing. A massive star that should still be there has simply vanished. No supernova, no debris, no fading glow, just gone. This isn't some sci-fi thriller. An international team has found 798 stars that have quietly disappeared between old surveys and modern ones. They've just ghosted us. This isn't an astronomical oops, a glitch. It's a serious challenge to how we think stars die if they really simply died. Or, for those who like things spicy,
aliens! Aliens!
Yeah, alien megastructures blocking the light. That's a real hypothesis.
I knew it. Aliens are always behind these stuff. But how did we find stars are missing?
Good question. But first, let's talk about how stars are supposed to die, because that's what makes this whole thing so weird. Stars don't just vanish. They have very predictable endings. Smaller stars, like our sun, lead gentle, well-behaved lives. When they run out of fuel, they swell into red giants, hundreds of times brighter and larger than before. Then they puff away their outer layers, forming a glowing planetary nebula, a kind of cosmic farewell that can shine for billions of years. What's left behind is a white dwarf, a dense, cooling ember that will quietly fade over eons into a black dwarf. But massive stars, the ones more than 8 times the mass of the sun, go out with a lot more drama. When their nuclear fuel runs out, their cores collapse and they explode in spectacular supernovas, events so bright they can outshine entire galaxies for weeks. These explosions scatter heavy elements through space and leave behind neutron stars or black holes. And crucially, we see these explosions. They're impossible to miss. They light up the sky, leave expanding debris clouds, and their remnants stay visible for astronomers to study for centuries. So when a massive star simply disappears, no explosion, no nebula, no fading afterglow, that's not in the script. That's not how stars are supposed to die. And that's exactly what makes these 798 vanished stars so deeply unsettling.
Okay, now I'm actually worried. But how exactly did we even find out they're missing?
It all began with a single disappearance. In 2016, astronomer Beatriz Villarroel compared 2 vast maps of the sky, one drawn from mid-20th century photographic plates and another captured by modern digital surveys. Stars shouldn't simply vanish. They may dim, flare, or die spectacularly, but they don't disappear without a trace. And yet one had. It was visible in the 1950s, shining faintly among countless others. And now it was gone. Not hidden behind dust, not drifting out of sight, just gone. That single anomaly became the spark for the VASCO project, short for Vanishing and Appearing Sources during a century of observations. The goal is simple. Turn the sky itself into a mystery puzzle, comparing decades of images in search of objects that had quietly slipped away from existence. The best data come from the Palomar Observatory's 1950s surveys, an era when the sky was refreshingly uncluttered. No satellites, no space junk, no accidental disco balls reflecting sunlight. Anything missing from those plates is the real deal. To track these vanishings, the team blends old-school detective work with cutting-edge tech. Computers align the old and new images. Machine learning flags suspicious changes, and human volunteers, the citizen scientists, double-check what the algorithms can't. Sometimes it takes an actual pair of eyeballs to tell the difference between a vanished star and, say, a thumbprint on the original glass. It's basically cosmic Where's Waldo, except the stakes are existential. Of course, not every missing star has died in silence. Some are simply hiding behind massive clouds of dust and gas, which can dim a star by 95% or more, like a cosmic photobomb that lasts for years. Eventually the dust clears, the light returns, and the universe carries on. It's not thrilling, but it's the first explanation astronomers must rule out before declaring a new kind of stellar death. So far, the VASCO team has uncovered two main kinds of disappearances. Long-term vanishings, the 798 stars that faded away and never returned, and brief, unrepeatable flashes that appeared on old plates for mere minutes, then vanished forever. The first group may be the result of something called a failed supernova. Normally, when a star more than 8 times the mass of the Sun runs out of nuclear fuel, it ends in a spectacular explosion, a Type II supernova scattering heavy elements across the galaxy. Every atom of iron in your blood and calcium in your bones was forged in one of those cosmic deaths. But sometimes, the story ends quietly. Instead of exploding, the star collapses under its own gravity. The shock wave that should have blown it apart never forms. Instead, the whole thing just implodes, falling inward until it disappears behind its own event horizon.
Where's the firework? No bang, no boom. Did it just ghost us?
Yep, gone without a trace.
So what do we call it?
Failed supernova, or a direct collapse.
Can't you get something more poetic?
Nope, I'm no Shakespeare.
The neutrino, also known as the ghost particle, is the key accomplice in this vanishing act. It can pass through an entire planet without even noticing. During a core collapse, an absurd amount of energy, roughly equal to the Sun's entire lifetime output, is released in seconds. But if that energy escapes symmetrically as neutrinos, it can't power an explosion. The star's core just keeps sinking inward, forming a black hole with no fireworks, no leftovers, no fuss. This isn't just theory. In the Large Magellanic Cloud, astronomers found a system called VFTS 243, a massive star orbiting a black hole that seems to have formed quietly, without the kick a supernova blast would leave behind. And in 2009, another star, N6946BH1, brightened briefly and then vanished. Follow-up images from Hubble and Spitzer showed nothing. It might have collapsed straight into a black hole, uncelebrated and unseen. As for those brief 1950s flashes, the ones that appeared for minutes, then never again, when the team compared the dates, they noticed a bizarre coincidence. Those transients often appeared within a day of nuclear weapons tests. The likeliest culprit wasn't a cosmic phenomenon at all, but fallout from Earth's own experiments, radiation in the upper atmosphere, possibly Cherenkov radiation, creating false signals on photographic plates. In other words, the Cold War literally confused our telescopes. And then there's the wild card, alien engineering.
That would be a Dyson sphere. If a Type II civilization wanted to capture all their star's energy, they'd build a Dyson sphere, a massive structure that wraps around the entire star. Since we're currently a Type 0 civilization, around 0.7 on the scale, should we even call ourselves Type 1 yet?
Not until we can harness all the energy available on Earth. And we will become a Type 2 civilization when we can harness all the energy from our Sun, and a Type 3 civilization when we can use all the energy of the Milky Way galaxy. But to get back to the topic, if an advanced civilization did build a Dyson sphere, to us, it would look as if the star had vanished in visible light, replaced by a faint infrared glow as the structure radiated waste heat. Freeman Dyson proposed this in 1960. If anyone were hiding behind one, the data from a project like VASCO is exactly where we'd expect to find evidence. So far, though, there's no convincing proof. No missing stars surrounded by suspicious infrared halos.
Really? Or maybe those aliens are just too far away for us to observe the infrared glow clearly. Or perhaps they're very good at stealth technology.
That's a possibility. But for now, let's focus on what we do have evidence for. Some Aladabu's Turk's quietly important type emissions are huge. It would mean a significant fraction of massive stars don't explode. They just fade into black holes. That changes everything from how galaxies evolve to how they manufacture heavy elements. We may have been overestimating how quickly galaxies enrich themselves with metals, and simultaneously underestimating how many silent black holes drift invisibly through the Milky Way. To catch one of these quiet deaths in real time, astronomers are turning to the Vera C. Rubin Observatory, which begins operations soon. Its legacy survey of space and time will map the entire southern sky every few nights, producing 20 terabytes of data per night, about 10 million potential alerts. That's too many for humans alone, So artificial intelligence is being developed to instantly sift cosmic changes from false alarms. If a star truly vanishes, astronomers will check every wavelength. The James Webb Space Telescope can confirm whether its thermal infrared glow is gone. X-ray and radio observatories can hunt for any lingering traces. Ultimately, it would be detecting a gravitational wave, a faint ripple in spacetime, as the collapsing core crosses the event horizon. Catching a star's light vanish and its death cry ripple through spacetime at the same moment would be the final, ultimate proof. The universe, it turns out, is far less predictable than the textbooks suggested. The VASCO team hasn't found the alien megastructure yet, but they're still looking. Because in science, as in life, the most interesting discoveries often begin with something that should be there, but isn't. Every vanished star is a mystery. And mysteries, in astronomy as in life, are what keep us looking up.